Thanks, Hernan. Hi, everybody. Thanks for joining us this evening, afternoon, or morning, I guess, depending on what part of the world you're joining us from. My name's Ron Lowry. I'm the Eastern Area Manager for Hazard Control Technologies, in addition to being an encapsulator agent specialist. My other hat is I've got 36 years in the fire service. I currently serve as a fire chief here in Pennsylvania in the U.S. So what we're going to talk about this evening is the use of encapsulator technology to help you with Class B, what we're going to call Class B liquid fuel spills. The agent also, as we were just talking earlier with some of our folks from down under, would also be a valuable asset for Class C down there, which is gaseous hydrocarbon releases. But in particular, what this is going to deal with is that this presentation is going to be liquid fuel spills, liquid hydrocarbon spills, and how F500 can help with that spill mitigation. So a little bit first, just about the company, Hazard Control Technologies, we're the manufacturers of F500, kind of like our mission statement that we want to make the world a safer place through leadership in fire prevention and protection, utilizing that eco-friendly, innovative technology. For those that on the call that aren't familiar with encapsulator technology, I think you'll see as we go through the presentation that it is quite different than foam or other technologies that are out there. And the eco-friendliness because of the fact that the agent's 100% biodegradable and contains no fluorinated compounds. It's very environmentally friendly as opposed to a lot of the agents that are out on the market today. So the HCT itself is headquartered just outside of Atlanta, Georgia. But as we can tell from the call today, we have a global reach. We have folks from Australia, New Zealand to Africa, to South America, Canada, and the US on the call today. So it's a US made product with a global reach. We have either subsidiary companies or distributors on every continent other than Antarctica. So, it's a widely used product, not just something that we're using here in the US. We also understand the importance of, putting ourselves out there, helping to advance the technology. We are members of the NFPA. We have several employees that sit on various NFPA technical committees. We do help, write some of the things about encapsulator technology for IFSTA. And you'll see here in the near future, we're already in the updated fire brigades manual, some information about encapsulator technology in NFPA 18A. And there'll be some additional information coming out in the other manuals here shortly. Also, members of the Society of Fire Protection Engineers and Hazard Control Technologies is an ISO 9001 registered company. So we have that very strict quality control procedures in place. Gives all of our customers the peace of mind that the product they buy today will be the same product they're going to get a year from now, 2 years from now. So again, what we want to cover today is spill control using encapsulator technology. We're going to talk about encapsulator technology itself, the features of encapsulator agents, their applications, then the advantages in spill control and some economic comparisons with some of the other products that are out there. So our objectives today is to achieve an understanding of what that encapsulator agent is and how it differentiates itself from foams. We're going to explain the characteristics of an encapsulating agent and the proper application, how they work. And then we'll talk about some different industries where encapsulator technologies can be used. So the first thing is the encapsulator agents. These are agents that fall under NFPA. Hazard Control Technologies kind of invented the technology. The agent has some different properties than other agents out on the market. It can be used on Class A, B, and D fires, lithium-ion batteries, as well as those three-dimensional Class B fires, or in the case of, down under, our Class C fires involving either spray fires or vapor release type fires. It's the new technology for the new millennia. Within that 18A, F500 actually falls under that 18A section 7.7, the spherical Micelle stability test, and we'll go over that test protocol as part of the presentation today to show how the agent actually encapsulates hydrocarbons within that spherical micelle and render those hydrocarbons non-flammable. So, actual definitions of an encapsulator agent. What is it? Again, it's a water additive whose basic building block is a spherical micelle. Those micelles are capable of encapsulating carbon molecules and both polar and non-polar hydrocarbon molecules in both the liquid and the vapor state, thereby separating the fuel from the oxygen on a chemical molecular level, as opposed to a foam. If you're talking on like this, would be a spill control or a Class B application, where that foam is mechanically trying to separate the fuel from the oxygen, making bubbles, putting a blanket down. We're actually doing it molecularly, working on the chemical level of the fuel and the agent to having the agent bind on to that hydrocarbon molecule and render it non-flammable. The animated video here we're going to play that'll actually talk about the agent and what happens when an encapsulating agent enters the water stream and mixes with water, and how that spherical micelle is formed and why it forms.
Encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So this orientation of the water droplet with the encapsulating agent mixed in is what makes encapsulating agents and F500 work. So the skin being on the outside of the water actually gives you the ability for the agent to work on Class D metal fires, where most water additives, or as far as I know, no water additive or agent can work, because you get that interaction with the water and a Class D metal. Now you have that protective skin of F500 on the surface of the water, protecting that water droplet from the Class D metal. Changes the way the agent, changes the way the water cools from steam conversion to thermal conveyance, where those F500 molecules can absorb the heat and transfer that heat inside these micelles. And then particularly in the application we're talking about today with the hydrocarbon spills and or fires, these non-polar tails actually bind onto the hydrocarbon molecules, and all those non-polar tails, think of these spherical micelles as little empty chemical cocoons that we're going to put hydrocarbon molecules inside.
Encapsulator technology.
Come on. So it's kind of hard when you're trying to put into perspective how small a spherical micelle is and why it's so effective, and how many of them there are in the water to actually bind onto those hydrocarbons. So because we're talking about a molecular structure to measure a F500 molecule or a micelle, you would need to measure it in angstroms. The actual size of a molecular structure is 1 × 10⁻10th. So to put that in comparison, if a water droplet would be about the size of the earth, so something you could see, a micelle would be about the size of a pea. So you can just correlate with that how many micelles are actually inside of every water droplet. We're talking millions, if not billions, of these micelles. Those unique features that once that encapsulating agent mixes with water, what it does for you is rapid cooling, because we can cool much faster than plain water because we're not depending on steam. We're actually using the entire water droplet plus the surfaces of all those micelles to absorb heat. So we can absorb heat much faster than plain water. We can encapsulate those fuels. So the encapsulation of those flammable hydrocarbons within the spherical micelle, toxin reduction, and then again, as I said earlier, the agent is fluorine free. So that first unique feature is the rapid cooling, that the F500 skin on the surface acting like a thermal current in absorbing that heat into the micelles within the water droplet. That second one is the encapsulation of the fuels. The test that again is through this NFPA 18A section 7.7 spherical micelle stability test. That test is actually part of our ISO 9001 test protocol, so our quality control procedures. In addition to being an NFPA requirement, it's a requirement internally of our test protocols for every batch of agent that's made. What that test protocol involves is this 1:8:40 ratio plus the kinetic energy. So 1 part of F500 to 8 parts fuel to a minimum of 40 parts water plus the kinetic energy mixed together renders that fuel non-flammable, non-explosive. As you see here, it's actually a 2.5% solution, F500 in water to fuel. You'll see in a lot of our literature when we talk about, we're always talking about a 3% solution. Twofold reason for that. One, it gives us a safety factor of that other 0.5%. And most of the proportioning equipment that's manufactured has like 0.5, 1, 3, 6% settings. So that 3% is a pretty much standard setting on most of the agent proportioning equipment that's available on the market today. So it's just as easy to go with a 3%. It gives you a little safety factor. Plus, that's kind of a standard in the market for how we need to proportion equipment. Video here is actually going to be the president of the company, Mike Greiner, actually doing this
demonstrating the
spherical micelle test. I'm going to kind of turn the volume off here on Mike while walk us through it because the video's a little long, so we'll speed through it a little bit. What we have here is a gallon of gasoline that Mike's going to add to the pan. Then we're going to go ahead and add 16 ounces of F500. That's what's in the measuring cup here off to the side. So this is your 1:8:40 ratio. So 1 part F500 to 8 parts fuel. And now this garden hose has a 5 gallon per minute metered nozzle on it. So Mike will pull out his phone here and time it for a minute. We're going to go ahead and add a minute's worth of water to that mixture of F500 and fuel, which gives us our 1:8:40 ratio plus that kinetic energy. So the next part of the test protocol is we need to leave that solution sit for a minute for the encapsulation to completely take place. After that minute is over, you need to be able to take a torch and pass a torch across the entire surface of the fuel. I'll turn the volume back on. Actually here that the torch is on. the torch is being passed across the surface without having ignition. Now, if we had a good foam,
demonstrate that we have a torch.
You also wouldn't have ignition if we had a good solid foam blanket down on that fuel, because the foam would be doing its job. Oh, I just started it over. Sorry about that, guys.
And now,
so the second part of the test
after 2
is
hours,
we need to let the solution sit for 2 hours and then perform that same torch test again. So through the magic of you'll see the ground's dry. We're 2 hours later into the test. And again, passing the torch across the surface of the fuel without having any ignition. So what this test is showing us that we have a stable spherical micelle in the presence of high heat. So if that micelle wasn't stable and it was releasing the hydrocarbon, you would get a flare up. So we're using the heat as a way to show that we have a stable spherical micelle encapsulating the fuel. So that next unique feature is that the ability of the agent to actually improve visibility and reduce toxins. And it does that through the interruption of the free radical chain reaction. And the reason for that is twofold. One, because the agent can rapidly cool the atmosphere, which the energy that's created by the heat from the fire is what speeds up those free radicals. So we can drastically slow those free radicals down by cooling the atmosphere. And then secondly, the F500 is a much denser molecule than plain water. So water is about 18 grams a mole, the molecular weight of water. The molecular weight of F500 is greater than 1,000 grams per mole. So it's a much denser molecule. So once those free radicals hit that dense molecule, it's like throwing a ball into a mattress. The free radicals can't readily pass through the F500 molecules. So they're, for the most part, just absorbed. It absorbs the energy and they fall away. That's one of the ways the F500 can actually help improve the environment. Testing that was done that showed this, they were doing some burns down at Clemson University. They were burning toluene, where they were injecting both a plain water mist into the smoke column and a 3% solution of F500 into the smoke column. Things they were looking for was light transmittance through the smoke. So what was the opacity of the smoke? What kind of soot accumulated? So how much of the byproducts of combustion were created? And then lastly, the soot in the smoke toxicity. So what kind of toxins were found in that smoke? So when they looked at F500 versus water, what they found is there was a 68% increase in visibility, a 97% reduction in soot, and a 98.6% reduction in soot toxicity. And the reason they theorized that was happening was that interruption of vapor phase combustion, inhibiting the radical coalescence into soot particles. So actually stopping that soot from even forming in the smoke. The last thing is, again, that fluorine-free advantage. You know, F500 giving you the ability to extinguish class A, B, D, and K fires, lithium-ion battery fires, without fluorines being in that solution. So in most states here in the US, and I know worldwide, that PFAS concern is major and everybody's looking for a solution. F500 is that solution. So we have multiple applications that the agent can handle, everything from flammable liquid spill control that we're talking about today to both class A and B fire suppression. In the case of the class B, both polar and non-polar, class D and K, as well as the lithium-ion battery and transformer fires. Quick video here where we'll go over all the different types of fires that F500
Hazard Control
actually
Technologies
successfully
presents
completed
F500
or
encapsulator
extinguished,
technology.
and then we'll actually get into the spill control aspects of the agent, what we're here to talk about today. So as you see here, we have Class A, basic combustibles, those pallets. Tires, a more difficult Class A fire. Again, rapid suppression, that black smoke disappearing, vehicle fires, that vehicle fires being extinguished with a 20-gallon per minute nozzle. So very low flow, very rapid extinguishment. The Class B, non-polar, regular hydrocarbons, so that's a diesel pit fire. Polar solvents, that's ethanol, E85 gasoline, so 85% ethanol fuel. The expanded capabilities of an encapsulating agent, so a three-dimensional flowing fuel fire, that's jet fuel and a simulated jet engine cowling. So that vapor state encapsulation, that's actually propane, so a gaseous encapsulation. Lithium-ion battery suppression. Class D fire suppression, that's magnesium turnings and fines. And this last one here is a substation-based transformer in Westchester County, New York. The Fire Department of New York and Con Edison, the power company, have done testing and have standardized on F500 for transformer firefighting in their locations. So when we talk about the advantages of using F500, an encapsulating agent for spill control, the same principles that apply that make F500 such a useful tool for firefighting and firefighters for fire suppression, the same things apply to those hydrocarbon spills. You know, the F500 has the ability to rapidly encapsulate that fuel, render it non-flammable, and take that flash fire problem away. So, render that fuel non-ignitable. If the firefighters have to work in that environment, makes it safer for them, makes it a much safer scene for everybody. That encapsulated fuel will remain in that non-ignitable state almost indefinitely, unless it's containerized. So if you would have it inside this tank and would seal the tank up, the agent will allow the fuel to evaporate slowly, but it evaporates at such a slow state that in the open atmosphere, you never reach an ignitable level of gas because it's releasing so slowly. If you containerize it and you trap those vapors that are slowly being released to evaporate off, you will have some trapped vapors that potentially could ignite, but the liquid itself won't burn. You would just have a flash of the trapped vapors that were in the vessel, not actually the fuel itself burning. So just a clarification there, within a confined environment, if it's a concealed vessel that has fuel encapsulated in it and it's locked up, over time, you could get some flammable vapors back inside that container again. So that fuel, water, and F500 solution on a hard surface, as I said, can just be left to evaporate if local regulations allow that. If you're applying a foam to that, you're really doing nothing to alter that fuel. Eventually, that fuel is going to have to be picked up, cleaned up somehow. The foam's really doing nothing to take the hazard away. The same as applying absorbent down. I think even more so than foam, that absorbent seems to be the go-to. I can tell you, at least in the fire service with most fire departments. But again, all you were now making is a flammable granular substance that potentially is off-gassing fuels. And if you put it into a bag and load it into your apparatus, if it finds an ignition source, it's going to burn. It's not, once it's absorbed into that kitty litter or that speedy dry, that it's now non-flammable. You just now have flammable speedy dry. So let's look at the economic comparisons of foam to F500. So if we look at the NFPA 11 foam standard and what it tells us about applying foam onto a hydrocarbon spill, it states that that foam must be applied for 15 minutes to mitigate the spill. So you're using an application rate of 1 gallon per minute per square foot for a 15-minute duration over a hydrocarbon spill. When we compare that to F500, again, we have that 1:8:40 ratio, that 2.5%, again, call it a 3% solution for easy math and the equipment that we have, so we can render that fuel non-flammable. So let's look at a real world situation. So if we had an 8-gallon fuel spill, that fuel spill is going to spread out to about 800 square feet. So for that 8-gallon fuel spill, it's going to require a gallon of F500 and 40 gallons of water. So that 1:8:40 ratio. So with an 80 gallon per minute nozzle set at 3%, it's going to require about a 30-second application onto that fuel spill to render that hydrocarbon non-flammable, non-explosive. If we're applying an AFFF foam onto that at that same 80 gallon per minute application rate for the NFPA recommended 15-minute application rate, you're now going to be using 1,200 gallons of water and 36 gallons of concentrate. So again, a much higher, both runoff, diking, cleanup after the fact, much higher application of the product you need. So when you're looking at the economics, a gallon of F500 can achieve what 36 gallons of foam. So we can neutralize the fuel with a gallon of F500 as opposed to just blanketing it and really not doing anything to alter the flammability of the foam once that blanket breaks down with 36 gallons of concentrate. So again, if we look at that for that complete fuel neutralization with the 1 gallon of F500 versus that temporary blanket that you need 36 gallons of AFFF to create, that then gives you a 40-gallon cleanup if you have to clean up of the F500 solution versus over 1,200 gallons of the flammable liquid solution to clean up. With the F500, you have a safe scene with the ability of firefighters to work in it within 30 seconds, as opposed to, a semi-safe scene of potentially if it's a vehicle accident, say with a fuel spill, and we have to try and get somebody out of that vehicle, we're then walking through that foam blanket, potentially breaking the blanket down, exposing flammable vapors that then have the ability to ignite. So it's a semi-safe temporary blanket as opposed to a safe, permanently neutralized fuel on the ground. Last thing is, as part of that, F500 is listed here with the US EPA as a surface washing agent. So it's actually listed with our Environmental Protection Agency saying that it's approved to use to treat that hydrocarbon spill on the ground. There's no foam that has that EPA surface washing listing like the F500 encapsulating agent does. So video here will just show a typical fuel spill cleanup. So you have your fuel spill on the ground. We're going to be using a 95 GPM nozzle here to treat that fuel spill. As you see, he ignites the other half. The treated fuel is now non-flammable.
This demonstration shows a large gasoline spill. Half is treated with 3% F500 solution. Flame is applied but only ignites the non-treated area. Then the fire is extinguished using a dispersed spray.
So he'll go in now with the hand line, finish extinguishing the fire. again, is that overall test. He'll come back through with the torch, showing that that fuel was non-flammable, non-ignitable. As you can see, he's walking right through the encapsulated fuel. Unlike a foam, there's no blanket to break down. There's no vapors being released from walking through that fuel. I don't know what just happened to my computer. Go away. Oh. So this video, when we're talking purely about an encapsulation capability, so this was actually out in Arizona. This was a tank, a fuel tanker that overturned over a hillside where they actually used F500 to initially mitigate the flammable vapors so that they could then send crews down to attach these hoisting cables onto the truck to try and get the balance of the fuel out the truck and safely get that truck on the highway. So you'll see here the fuel running out of the tank on the truck where they've emptied it. They're applying a 3% solution of F500 to encapsulate that fuel, keep the explosive gas levels down to make that a safe operation. So applications here, you know, going beyond, you don't have the ability to put absorbent down on this. That's a three-dimensional down over a hillside. We can't put a foam blanket on that because as soon as you lift the trailer, you're going to be lifting it out of the foam blanket and exposing those fumes if you could even get a blanket formed. Another way that an encapsulating agent expands your capabilities and allows you to do things that no other agent on the market currently allows you to do. So greatly improving your ability to provide safe operations. This next video, this is from down in Chile, a different kind of spill treatment. So this was actually from a truck accident that was hauling sulfuric acid. Again, no other agent that I know of, the testing they've done in Chile, we can actually treat sulfuric acid, neutralize it without having an exothermic reaction. So the first attempt that was made at this spill was to bury the sulfuric acid, but it was off-gassing and putting up vapors that they couldn't have. So they brought in a hazmat team that uses F500 to actually come in and treat the spill to neutralize the acid and make it a safe working environment. So when we talk about the advantages of F500 in these real life type situations, you can see that there's much less agent used, which is less expensive for the departments that are using it, much less water used. You know, when we're comparing a foam application to an F500 application, if it's a rural water supply situation, less tankers needed, you know, that type of stuff. Less potential for issues with the EPA or the local jurisdictions, Environmental Protection Agency, from runoff from all the excessive amounts of water that you may need to use. It gives you then less cleanup cost if you have less solution to clean up. Easier on your firefighters, they don't need to be on scene as long. And again, making that scene safer by actually encapsulating the fuel and not just covering it up with a foam blanket. So again, the encapsulator agent, it's a unique category of agent for both fire suppression and spill control. For the particular spill control that we're talking about now, it encapsulates those hydrocarbons, rendering them non-flammable. It helps speed up the bioremediation process. So it allows those hydrocarbons to bioremediate faster. out of the soil if that's what happens, and you can leave it there. Reduces the amount of concentrate that's needed to affect spill cleanup. Again, reduces the amounts of runoff. And as we saw in the last application with the tanker over the hillside, it can be used in applications where foams and absorbents can't be used. So again, expanding your capabilities. The agent itself can be used in either fixed suppression systems or for some of the industrial settings if you know, there aren't fire apparatus available. We have the larger, quicker attack units that can be used the same way. It's a 3% solution that can be used to treat a hydrocarbon spill. We have F500 carts that carry a supply of concentrate that's fed by a fire hose and educted into the fire line to do it. Again, our CCS systems, which are tied directly into sprinkler systems, more in an industrial setting to help control a vapor release or a fuel spill. We also offer consulting and training on various aspects, be it, you know, fire protection assessments, dust hazards analysis, emergency response planning, any type of training along those routes, either with particular materials we're used to dealing with, like the coal and other combustible dusts, or even like this with, you know, ethanols and some other fuels where we have some experts at the company that can help, you know, with those type of consulting and training needs.